Hello everyone, welcome to today's video on solving systems of equations by using the elimination method. So this is within the algebraic way of solving systems of equations, similar to substitution. The elimination method is often considered to be easier. I don't like it as much, but it's often considered to be easier by students. It kind of depends on what the problem is. For some problems, using the elimination method is always the best method, and that's what I would go with. So to solve a system using the elimination method, the idea is that we add or subtract the two equations in the system together, like right on top of each other with the x and y variables lined up, and then we solve the resulting equation. That resulting equation is normally pretty easy to solve, and the idea is that we're eliminating one of the variables, so we just get a one-step equation, like 2x equals negative 2 to solve. Once you find one variable, just like in the substitution method, you substitute what that variable is equal to into one of the other equations and solve for the missing variable. Okay, so let's look at some examples. So here we have solve the system of equations by elimination. So when I look at this problem, I can see right away that an elimination approach is going to make a lot of sense. To know that, I see that my x and y variables are lined up, right? Here are my x's, here are my y's, and then there are my constants. And then if I pay attention to the coefficients, for my 4 and my negative 2 coefficients, if I add and subtract 4 and negative 2, I'm not going to eliminate the variable. If I subtract it, I'll get 6x. If I add it, I'll get 2x. Though that's not going to make it go away. We want to get one of the variables to have a coefficient of 0, which we know eliminates it. It goes away. Okay? But I do have that here in my second situation. I have a negative 3y. We know minus 3y is the same thing as adding a negative 3y. So negative 3y. And then I have a positive 3y here. So if I add these two together, negative 3y plus positive 3y, I'm going to get 0y, or just 0. Thus, I'll be eliminating the y variable. Okay? Now, you might ask, wait, why can I just add these together? The idea behind the elimination method is that you can always add or subtract the same thing to both sides of an equation. So it actually is very related to substitution, right? This negative 7 is equal to negative 2x plus 3y, according to this situation. So I can take my original equation, add negative 7 on the right-hand side, and then add negative 7 on the left-hand side, but we know that negative 7 is equal to negative 2x plus 3y. So we can ultimately just add straight down, add the equations together. Okay, so let's do that. For my x's, I have 4x plus negative 2x. What is 4x plus negative 2x? That is positive 2x, so I get 2x here. Okay, then for my y variables, I have negative 3y plus 3y. What's negative 3y plus 3y? 0, right? Just 0. It is 0y. But it's just 0, it goes away, we're getting rid of our y term. And then here we have 5 plus negative 7. 5 plus negative 7 is negative 2. Okay, so then I just get this equation, 2x equals negative 2. Because of course, adding 0, we don't need to write that, because adding 0 does not do anything. Okay, and then we basically have our x value. So x is currently being multiplied by 2x, so we can undo that by dividing both sides by 2, and we get that x equals negative 2 divided by 2, which is negative 1. Great. Okay, so again, the strategy that I did there is I noticed that for my y variable, I had these opposite coefficients, negative 3 and 3, and we know that opposites sum to 0. So when I see these opposite coefficients, I'm going to add the equations together, and then that will eliminate the y variable in this case. Great. Okay, so I found x equals 1. Am I done? Is that my solution? No, because for solutions to systems, we need the x and the y variable, and then we write the solution as an ordered pair. So I did this. Now let's find my y variable. Now that I know the x value is -1, I can choose either of these original equations. It does not matter. I'll go with the first one, 4x plus -3y equals 5. And I can substitute in for x this -1 because, again, x is equal to -1. So where I have x, I can substitute in for -1. Okay, then I get -4 plus -3y equals 5. I need to get y by itself. This is a -4. I can undo that -4 or get rid of the -4 by adding 4, positive 4 to both sides. Or we could think of it as subtracting a -4. But 4 plus -4 is 0, so that will cancel away. And I'll just have -3y on the left-hand side, 9 on the right-hand side, and then, of course, divide by -3, and we'll get y equals -3. Thus, x equals -1, y equals -3. What is the solution to this system? Yep, it is the coordinate point ordered pair -1, -3. If we were to graph these two lines, those lines would intersect at the point -1, -3, and that is the x value and y value that makes both equations true at the same time. Awesome. All right, let's take a look at another example here. Here I have 2x plus 5y equals 18, and then 2x plus 5y equals 15. So at this stage, I look at the coefficients. We'll just start with the x, and I'll see, okay, I have 2 and 2. So those coefficients are the same. So if I have 2 and 2, and I'm trying to eliminate the x value, I'm trying to get to 0. How do I get, with 2 and 2, how do I get to 0? Do I have to add those or subtract them? Yeah, 2 minus 2 is 0. So whenever we have the same coefficient, the number that the variable is being multiplied by, that's when we want to subtract the equations. Okay, so I'll rewrite this. 2x plus 5y equals 18. 2x plus 5y equals 15. And then we're going to subtract. Okay, we have to be careful with this subtraction. People often make mistakes here. We're subtracting every single term. So first I have 2x minus 2x. What's 2x minus 2x? 0 or 0x. Okay, then I have 5y minus 5y. We're subtracting there as well. What's 5y minus 5y? Also 0. Okay, and then finally I have 18 minus 15. What's 18 minus 15? 3. Okay, so then I get 0 equals 3. Is that true? Does 0 equal 3? No, that's not true. Okay, so there are no solutions to this system of equations. Whenever I get a false statement like this, then we can conclude there is no solutions. These two lines are parallel lines. If we were to graph them, they are never going to intersect. You might have been able to figure that out from inspection immediately when you looked at this. There's no x and y value that makes both 2x plus 5y equal to 18 and 15 at the same time. So there's no solutions. I can see that when I subtract these, right, both the x terms and the y terms are going to eliminate, and on the right-hand side, we're going to get something that is not 0. If we had the exact same equation, this was 15 and 15, then we would get 0 equals 0, which is true no matter what. They'd be the same line, and we'd have infinitely many solutions. Okay, awesome. There's one other situation to talk about. So elimination is great when we have a situation like that, where when we look at the coefficients, immediately the terms are going to cancel and eliminate. However, that's not always the case. It doesn't always work out that way. So in this example, we have 6x plus 5y equals 19 and 2x plus 3y equals 5. If we try to add or subtract these equations, which we can, that will be true, that will be fine. We will not eliminate one of the variables. 6 plus 2, 6 minus 2 does not give us 0. 5 minus 3, 5 plus 3, we don't get 0. So we cannot currently just add and subtract to eliminate a variable. Instead, what we can do then is you can multiply one or both equations by a constant so that adding or subtracting will eliminate the variable. So I'm going to show you just that step. So here's that same problem. I notice, again, adding and subtracting will not eliminate one of the variables. So I'm going to try to multiply one of the equations so that I then can eliminate one of the variables by adding or subtracting. It's normally easier to pick like a multiple. So I can think 2 times what gives me 6. That will allow me to eliminate something. Over here, 3 and 5. 3 times something does equal 5, but it's not a whole number, so we don't like it as much. Okay, so let's try to eliminate the x's. So I have 6x and 2x. If I could make this 2x 6x, then I could subtract the equations, and I'd be good, and I would eliminate the x. 2x times what will give me 6x? Yeah, 2x times 3. But we can't just multiply that by 3. In order to keep an equation true, we know what we do to one side, we must do to the other. So we're going to take that second equation, 2x plus 3y equals 5, and we multiply the entire thing by 3. So that means every single term. So this side by 3, both of those terms by 3. So 3 times 2x, that's 6x. 3 times 3y is 9y. And then on the right-hand side, 5 times 3 is 15. That's still equivalent to the original equation because we did multiplying by 3 to both sides of the equation. Okay, so then I can rewrite my system. 6x plus 5y equals 19. That's the original one. And then 6x plus 9y equals 15. At this stage, I can subtract these. 6x minus 6x is 0. 5y minus 9y is negative 4y. And 19 minus 15 is 4. So I'll get negative 4y equals 4, so y equals negative 1. Then you would substitute in negative 1 for y here, figure out what x is, and give you the solution. Just like I'm going to do really quickly here. Awesome. All right, that's all it is. Great job, everyone.